Hi guys, welcome back to my channel. In today's video, we will explore Bernoulli's differential equations, right? An important type of non-linear differential equation. This is not linear, this is non-linear differential equation, okay? Right, that frequently appears in your engineering courses and applied mathematics. We will understand its structure, why it matters and where it is used in real world applications, right? Let's get started. Why Bernoulli's equation is so important, right? Bernoulli's equation appears in many engineering and scientific applications. In lot of fields, these equations are applied because it models systems where growth, decay, or resistance follows a non-linear pattern. Some key application includes, where are the topics it is included? As usual, your fluid mechanics, and the second one, electrical circuits, right? And then the third one, chemical reactions, for chemical engineering, chemical reactions, okay, right? And then the fourth one, population dynamics, okay? And the fourth one is population dynamics, right? In fluid mechanics, where we can use, of course, it's used to analyze the fluid flow. In electrical circuits, where we will apply, we can model non-linear resistance in circuits, right? And what about the chemical reactions? It describes the reaction rates with concentration dependent terms. And population dynamics, of course, population connected with biology. So it's used in biological models with growth constraints, right? So what is Bernoulli's differential equations pattern? So how it looks like? So Bernoulli's differential equation looks like in the model dy by dx plus py is equal to qy power n. There is an extra fitting. Can you see that? Yes. P is a function of x, which you already studied in the first order linear differential equation, and q is also function of x. And there is one extra y power n is coming in that. If this situation occurs, then that equation is called as Bernoulli's differential equation. And keep in your mind, this n is equal to 0 or n is equal to 1. N is equal to 0 or n is equal to 1, right? So if you become n is equal to 0, this is y power 0. If you put n is equal to 1, it will become y power 1. Can you understand? Y power 0 and y power 1. What do you call this one? Y power 0 and y power 1. Y power 0 and y power 1, we call it as linear differential equation. So keep in your mind, Bernoulli's differential equation, n is not equal to 0 and 1. If n is equal to 0 and n is equal to 1, automatically the equation becomes linear. So n is not equal to 0, n is not equal to 1 becomes Bernoulli's differential equation. Okay. And how it can be solved? It can be solved by the same manner, the special method which is called substitution method. This is called what? Substitution method, right? So in substitution method, in the last one, we used y is equal to vx. For all the questions related to substitution method, we used y equals vx. But here in this Bernoulli's method, I am not going to use vx. Problem to problem, the substitution differs. Keep in your mind, for each problem, the substitution is different. Not like the previous method, here it is different. The substitution differs. So it means, how can I find it, teacher? No problem. Each question I will tell you where is your substitution. Okay. So once again repeat, Bernoulli's differential equation is the model dy by dx plus py is equal to qy power n. Whereas n is not equal to 0 and not equal to 1. Because this is a non-linear differential equations. And this one, if you put n is equal to 0 and n is equal to 1, then automatically the differential equation becomes linear. So this case is not allowed. So in this case, how we are going to solve this Bernoulli's differential equation? We are going to use substitution method. So in last video, we saw the substitution method y equals vx, right? So if I use y equals vx and later I'll be using variable separable method. Did you notice that? I'll be using variable separable method. So the last stage I'll be separating dv by dx, right? I'll be separating dv by dx. With that I will go for v solution, right? So I'll be using variable separable method. Whereas the Bernoulli's differential equation, once I use the substitution method, automatically it will be converted into first order linear differential equation. Can you see the beautiness? First order linear differential equation, right? First order linear differential equation, right? So it is a nonlinear differential equation. Because of our substitution, automatically Bernoulli's equation takes the form first order linear differential equation. So this is a small introduction about Bernoulli's differential equation. In the next video, we will see how to solve a Bernoulli's differential equation. Thank you for watching. Have a good day. Take care. Bye bye.